Hey everybody, welcome to Algebra 1-2, Section 11-4, Adding and Subtracting Rational Expressions. By the end of this lesson, you should be able to add or subtract rational expressions with like denominators, add and subtract rational expressions with unlike denominators. And we're going to explore both monomial denominators and polynomial denominators. So let's start with adding with like denominators. This is the easiest thing of the lesson. So let's go old school, like fourth grade, where we're adding fractions. Okay, so 3 steps I want to do real quick. First, make sure that the denominators match, which in this case they do. They're both 4. So then you go ahead and you add or subtract the denominators while leaving the denominator the exact same. So I'll add the 3 and the 7 and make 10, and that 4 stays on bottom. Last thing you want to do is once you have that single fraction, reduce your final answer if you can. So it looks like 2 goes into both of those, so that'll reduce down to 5/2. And we're going to keep those 3 steps all the way through this lesson. Make the denominators match, add or subtract the numerators, and then reduce your final answer. Okay? So it might be a good idea to go ahead and write those down. So let's do it not fourth grade style, but let's do it with rational expressions. So here I have 5 over x minus 3 plus x over x minus 3. So step 1, make sure your denominators match, which they do. Step 2, go ahead and add your numerators. So 5 plus x is just 5 plus x. Okay, not 5x, which means 5 times x, but 5 plus x. So then double check. Do those things reduce? Well, they don't match, and I can't factor anything, so nope, it doesn't reduce. That's my final answer. Some people might say, well, don't the x's cancel out? No, because the x is part of a sum. Okay, I can't take 5 plus x and cancel one of them out. If I want to reduce 5 plus x, I've got to cancel it out with another 5 plus x. Let's try another one. X over 4x plus 8 plus 2 over 4x plus 8. Let's make sure the denominators match, which they do. Then go ahead and add up those numerators. So I get x plus 2 over 4x plus 8. Last thing I want to do is check, can my answers reduce? Well, as of right now, no, they can't, but I think I can factor that denominator. So if I take x plus 2 over 4x plus 8 and factor out a 4 as the GCF, I now have x plus 2 over 4 times x plus 2. And now I can go ahead and cancel out those x plus 2's. So what's left? I've got a 4, but that 4 is in the denominator. And if there's nothing left in the numerator, we just put a 1 there. So that whole mess from the beginning just reduces down to 1/4. So now let's start talking about subtracting. We've done addition all the way up to this, but now let's start talking about subtracting. It's not too terribly different because what we're going to do is we're going to turn it into an addition problem. So if I've got 3x minus 8 over x plus 5 minus 2x plus 4 over x plus 5. So step 1, make sure your denominators match. They do. Add or subtract the numerators. Now here's the key to any subtraction problem. Let's change it to an addition problem by distributing that minus sign. So I'm going to distribute it to the 2x and distribute it to the 4. And that'll give me that first fraction plus negative 2x minus 4 over x plus 5. Okay? So a good way to think of that is you're subtracting everything in that second fraction, everything in that second numerator. So I'm subtracting the 2x, I'm subtracting the 4. And I find that people who distribute it and visually show it in front of those numbers do much better. So now that I've got that minus sign distributed, it's just an addition problem. So I can go ahead and combine like terms. So 3x minus 2x is just x, and negative 8 and negative 4 makes negative 12. So I've got x minus 12 over x plus 5. Let's double check if that reduces. Right now they don't. Nothing can factor. There we go. That's my final answer. So main point from this slide is if you have a minus in between the two fractions, just distribute that minus to everything in the second numerator. So now let's talk about how to do fractions when the denominators aren't alike. So again, let's kick it old school. Well, if we have something like this, first thing you want to do is find the greatest or the least common denominator, the LCD. So in this one, it's going to be 24 because 24 is the smallest number that both 8 and 6 can go into. So once you establish what the LCD is, we want to create each fraction to have that LCD of 24. So for the first fraction, I need to multiply by 3 in order to make it 24. In the second fraction, I need to multiply it by 4 to make it 24. So I end up getting 15 over 24 plus 4 over 24. And now it's just like what we were doing before. Make sure your denominators match, add up the numerators, and then see if it reduces, which it doesn't. So that is my final answer. Now, what happens when you've got something other than just numbers there? What if you've got some variables going on? So we're still going to find the LCD. And so let's just start and do one thing at a time. So if we take a look at just the numbers, what's the LCD between 9 and 7? The lowest number that 9 can go into and 7 can go into as well. Well, I think that'd be 63. So now what about the variables? Okay. Remember when we were doing GCF factoring, and I said, if they've got the same variable, you look for the lower exponent? Here it's just the opposite. If they've got the same variable, look for the highest exponent. So in this case, I'm going to say t to the 5th is part of our least common denominator. Okay, because I'm looking for something that's common to both of them. And the first one only goes up to t squared, but the second one goes all the way up to t to the 5th. So we have to accommodate that t to the 5th. If that makes sense. So there's my least common denominator, 63 t to the 5th. So now I need to multiply so that each fraction has that as its denominator. So in order to make the 963, I need to multiply by 7. And in order to make the t squared t to the 5th, I need to multiply by t to the 3rd. So I multiply both top and the bottom by 7 t to the 3rd. For the second fraction, I just need to multiply by 9 in order to make the 763. And the t to the 5th is already t to the 5th, so that's good. So when we multiply those out, I get 28 t to the 3rd over 63 t to the 5th plus 72 63 t to the 5th. So my denominators are the same. Let's go ahead and add up those numerators. Since they're not like terms, we can't combine them. And last thing we want to do is see if they reduce. Well, I see that the numerator has a GCF of 4, so I could factor that out, but that doesn't reduce with anything. So I think that's just it. Okay, nothing reduces. So I would accept either one of those answers as your final answer. Okay, now instead of using monomials as your denominator, what if we've got polynomials? So 1 over x plus 4 plus x over x plus 6. Now remember, x plus 4 and x plus 6 are two completely different things. I'm sure some people would say, well, don't you just add 2 to both top and bottom? And that's absolutely wrong. You can't add or subtract something to the fraction in order to make it with common denominators. You can only multiply in order to make common denominators. So don't add 2. Don't add anything to try to get common denominators. Instead, my common denominator has to have x plus 4 in it, and it has to have x plus 6 in it. So that would be my common denominator, is x plus 4 times x plus 6. So now let's go ahead and apply that to what's going on here. I want to make both denominators x plus 4 times x plus 6. So for that first fraction, I need to multiply by x plus 6. For the second fraction, I need to multiply by x plus 4. So now both denominators are x plus 6 times x plus 4. So in the first fraction, 1 times x plus 6 is just x plus 6. In the second fraction, x times x plus 4 is x squared plus 4x. So when I add those up, I get x squared plus 5x plus 6. Last thing I want to do is double check. Can anything reduce? So I think I can factor that numerator. into x plus 3 times x plus 2. But when I do that, nothing reduces. Okay, well, I tried, but that's just my final answer right there. X plus 3 times x plus 2 over x plus 6 times x plus 4. So let's go ahead and try a few other examples and kind of hammer this concept home. Okay, let's take a look at our first example here. A squared over a minus b plus b squared over b minus a. Now, remember on the previous example I said x plus 6 and x plus 4 are two totally different things. You can't do anything to make them the same. Okay, now in this one, I would say the same thing, except I notice a minus b and b minus a, those are opposite factors. So what I can do is I can factor out a -1 out of that second denominator, and I would get -1 times a minus b. Okay, now this is kind of an interesting example because with a -1, I can kind of transfer that negative to the numerator. And now that first fraction and the second fraction, they now have common denominators. So this is kind of a weird case, but I did want to make you aware of it, that if your denominators are opposite factors, you can do a little mathematic gymnastics here and make it work. So my equation is now a squared over a minus b equation. It's an expression. Plus negative b squared over a minus b. So now I've got common denominators. So now I can go ahead and combine those numerators. So a squared and a negative b squared over a minus b. Last thing you want to do is you want to go ahead and see if anything reduces. Right now they don't, but I can factor a squared minus b squared into a plus b and a minus b over a minus b. So now the whole a minus b can cancel out with this whole a minus b, and my final answer is just a plus b. Okay, let's try another one. Okay, so my denominators are a minus 4 and a plus 3. Those things have nothing in common, so my least common denominator is going to be a minus 4, and it has to have the a plus 3 on it. So that's my common denominator, a minus 4 times a plus 3. So I want to go ahead and multiply both fractions in order to make them have the exact same denominator. So this first fraction needs multiplied by a plus 3. The second fraction needs multiplied by a minus 4. Ugh, that's just ugly right there. Okay, so my denominator is going to be a plus 3 times a minus 4. And my other denominator is also going to be a plus 3 times a minus 4. Now, since the denominators don't change, they stay the exact same, there's no need to FOIL those together. However, our two numerators, we're going to want to FOIL those together so that we can possibly add the two numerators together. So don't FOIL the denominators, but do FOIL the numerators. For the sake of time, I'm not going to go ahead and show how you FOIL it together. I'm just going to write down the answer. That's going to be a squared plus 5a plus 6. I also need to FOIL together a minus 2 times a minus 4, and that will be a squared minus 6a plus 8. So the whole reason that I did that was so that I can combine the two numerators. So I see that I've got an a squared here and an a squared here. That's going to make 2a squared. I have a 5a minus 6a. That makes a negative 1a. And then a 6 and an 8 makes 14. Okay, so whenever you're working with polynomials in your denominator, go ahead and FOIL the numerators together or distribute to make the numerators come together. And then once you get it all FOILed out, go ahead and add them together. Now, last thing I need to do is double check, can that reduce? So we're going to have to use a little bit of magic number on that. So 2 times 14 is 28. I'm looking for two negative numbers that multiply to be 28 but add up to be negative 1. I don't think that's going to work out. So that numerator can't factor. Nothing cancels out. That's going to end up being my final answer there. Let's try a couple more. Okay, so here I have 5x plus 10 and 4x plus 8 as my denominators. Now, something that's going to be helpful is if we can kind of break that down, maybe we can find our LCD a lot easier. So that first fraction is going to stay x plus 6, but then that denominator is going to be 5x plus 2. And then for that other denominator, I'm going to get 4 parentheses x plus 2. So now I'm going to use that to find my least common denominator. So my common denominator has to have 5 in it. It has to have x plus 2. It has to have 4 in it. And it has to have x plus 2. But I've already got x plus 2 already in that list, so I don't need to repeat that x plus 2. So my least common denominator is going to be 5 times 4, which is 20, times x plus 2. Okay? So now let's take a look. What do I need in order to get those denominators to be 20x plus 2? Well, this first fraction only needs a 4 to turn the 5 into a 20. And the second fraction needs a 5. So I'll need to multiply by 5 there and multiply by 5 there. And when I do that, I'm going to go ahead and come on down here. I will get 4x plus 24 over 20 times x plus 2. Bring down the minus, and I get 5 times x plus minus 2, so that'd be 5x minus 10 over 20x plus 2. So now I have common denominators, my very first step. However, this is a subtraction problem. So I'm going to distribute that minus sign and turn it into a positive. So that'll be a negative 5x plus 10. So my steps, make sure they've got common denominators. Then go ahead and combine your numerators. So 4x minus 5x is a negative x. 24 plus 10 is a positive 34 over 20 times x plus 2. Last thing I want to do is double check. Can this be reduced? Well, negative x plus 34 can't reduce. It can't be factored. And so, yeah, nothing cancels out. So that's going to be our final answer here. negative x plus 34 over 20 times x plus 2. Let's take a look at one more example. Now, very similar to what we did before, to find our greatest common denominator, let's see if we can break down these denominators as much as possible. So that 3y stays the same, but y squared minus 7y minus 10, that can factor into y minus 5 and y minus 2. The second one, that 2y stays the same, but that can break down the denominator into y minus 5 and y minus 3. So my least common denominator has to have everything that my first denominator has. So it has to have the y minus 2. It also has to have the y minus 5. But it also has to have everything my second denominator has. So it has to have the y minus 5, which is already on my list, so I don't need to repeat it. But the y minus 3 is something new. So there we go. That's my least common denominator. It's got to have y minus 2, y minus 5, and y minus 3. So now taking a look at this, what is each fraction missing? Well, the first fraction is missing the y minus 3. So I will multiply by y minus 3. And the second fraction is missing the y minus 2. Okay. So now my denominators are the same. They all have y minus 5, y minus 2, y minus 3. So let's go ahead and fix our numerators. So that 3y times y minus 3 is going to make 3y squared minus 9y. Over y minus 5, y minus 2, y minus 3. And while I'm distributing that 2y, can I go ahead and distribute that negative sign with it? Let's go ahead and do that. So let's distribute that negative 2y. And so I get negative 2y squared. And negative 2y times negative 2 is a positive 4y. Okay, lots of places to make mistakes here. So make sure you're very vigilant about what you're doing. So y minus 5 times y minus 3 times y minus 2. Okay, so now the two denominators have like terms. All right, let's go ahead and combine our numerators. So a 3y squared and a negative 2y squared makes just a positive 1y squared. Negative 9y plus 4y makes a negative 5y over y minus 5 times y minus 3 times y minus 2. Okay? So there we go. We got everything all in one fraction. So we're good to go on that. Except I haven't checked. Can I reduce anything? So in order to reduce it, I need to check and see if I can break stuff down. So y squared minus 5y. Well, I see a GCF of y there. So y times y minus 5. And I think you should be picking up on this. That the y minus 5s can cancel out. So then my final answer is going to be y over y minus 3 times y minus 2. Whew, that was a doozy. Okay, if you guys have any questions on this, please let me know, either via email or ask me questions in class, and we'll spend more than one day on this because this is kind of a meaty topic here. So we'll get into some easier examples, we'll get into some more difficult examples, but I really want you guys to understand this. So I hope you guys are doing well. Hopefully this isn't too tough for you. I hope you guys have a good one, and I'll see you real soon. Bye.